Our second topic in stoichiometry is going to be limiting and excess reactant. Essentially, when you put two ingredients together, two reactants together, you are always going to run out of one of them first. No matter how hard you try, it's very, very difficult to get exactly the right amount of both. And a lot of times we don't even try to have the exact right amount of both. We just sort of, we control the reaction so that we intentionally have one reactant limit the reaction and essentially run out. So it's sort of like if you are making sandwiches and you have a full jar of peanut butter and a full jar of jelly and only a half a loaf of bread, the number of slices of bread limits how many sandwiches you can make. The same thing can be said of a chemical reaction. Okay, so go ahead and write down what you see on the screen right now, and then I'm going to go through an example with you. Okay, so let's look at this example. It says if you had 200 grams of silver nitrate available to react with 200 grams of sodium phosphate, which one's going to run out first? Of course, first we need a balanced equation. See if you can come up with that. Okay, so there's your balanced equation. You should have 3's in front of silver nitrate and sodium nitrate. And you notice it is a reaction because you have a solid precipitate of silver phosphate over here on the right. Okay, so the question is, if you have 200 grams of each reactant, so I have 200 grams of silver nitrate and 200 grams of sodium phosphate, which one's going to run out first? And we have the same amount of both, so your first instinct might be, well, if I have the same amount of both, then I'm not going to run out of either one. I have exactly the same amount. But two things. Number one, the balanced equation calls for 3 times as many moles of silver nitrate as it does sodium phosphate, so that's one thing to consider. And number two, a mole of silver nitrate does not weigh the same number of grams as a mole of sodium phosphate, so we do have to do a little bit of math. So anytime you're given amounts of both reactants, of 2 different reactants, you have to convert from grams of one to grams of the other that would be needed. In other words, I'm going to start, and it doesn't matter which one you pick, I always just kind of pick the first one, but I'm going to start with 200 grams of silver nitrate, and I'm going to see how many grams of sodium phosphate are needed to react with that. In other words, to fully use up this 200 grams of silver nitrate, maybe it's going to take more than 200 grams of sodium phosphate, maybe it's going to take less, but that's what I'm going to determine mathematically doing stoichiometry. So what I want you to do right now is go ahead and convert 200 grams of silver nitrate all the way to grams, so I'll just put a question mark, grams of sodium phosphate. So this is just like the problems that we've done so far. So you're going to have to go to moles of silver nitrate, and then you're going to have to go to, well, I'm going to run out of room, but you're going to have to go to moles of sodium phosphate on your way to getting grams. So just like this, and that will take me there. So go ahead and do that calculation from grams of silver nitrate to grams of sodium phosphate and see what you get. Okay, so hopefully you came up with the same answer I did, which is this number down here, 64.3 grams of sodium phosphate. And that amount, notice it's not how much I have. I have 200 grams of sodium phosphate. What I just figured out is how many grams of sodium phosphate I need to react with 200 grams of silver nitrate. So I'm even going to go ahead and just be very intentional about this, and I'm going to label in parentheses down here that this is the amount of sodium phosphate needed to fully react with my 200 grams of silver nitrate. And what this tells me then is if I need 64 grams and I have 200 grams, I have excess. I have more than I need of my of my sodium phosphate. So up here in the balanced equation, I'm just going to scribble a little ER for excess reactant, meaning that that is the one that I'm going to have some leftover of, just like the peanut butter and the jelly is what we had leftover of in the sandwich analogy. I have excess of sodium phosphate in this example. Okay, and then silver nitrate would become my limiting reactant, because then by definition, if I have excess of the other one, that means I'm going to run out of the silver nitrate. Now, if this number down here had been more than 200, so instead of 64.3, let's say I would have gotten, 350 grams of sodium phosphate needed after doing my stoichiometry. Well, then that would give me the opposite conclusion. It would tell me that, well, if I only have 200, then I need 350 or whatever, more than 200, then that would make my sodium phosphate my limiting. But in this case, I calculated that I needed less than I have. So that makes that sodium phosphate my excess and the sodium nitrate my limiting. Now the last thing I want to talk about here is, okay, how do we use that? So it says, based on the previous question, how many grams of silver phosphate would you expect to produce? So silver phosphate, now we're talking about a product. All right, we're talking about this guy over here. So if I want to calculate how many grams of silver phosphate I'm going to produce, or how many I should produce, do you think that that should be based on 200 grams of silver nitrate, which is my limiting reactant, and is going to run out, or do you think that should be based on 200 grams of my excess reactant? Okay, so hopefully you said you would base this calculation, or start this calculation, with 200 grams of silver nitrate because it's my limiting reactant. If it's what is going to run out, it determines how many grams of product I can make. Just like if I have 8 slices of bread and plenty of my other ingredients, I can only make 4 sandwiches. I calculate that based on my slices of bread because that's my limiting ingredient. So all you're going to do here for this last question is start with your grams of limiting reactant, 200 grams of silver nitrate, and convert that to grams of silver phosphate. Let's see what you get. Okay, and here's my answer. I got 164 grams of silver phosphate should be produced if I'm using 200 grams of silver nitrate, which I had already decided was my limiting reactant from the previous step. So it's just a gram to gram conversion. So again, I'm still just using the periodic table to go between grams and moles here and here. And I'm using the balanced equation to go from moles of one thing to moles of the other. I get 164 grams of silver phosphate. Now, I do want to say something that's going to kind of lead us into our next topic, and we're not going to say too much about it right now, except to say that this word expect is very important. 164 grams of silver phosphate is how much I would expect to produce. We have a special term then for this answer. We call this the theoretical yield. And of course, yields means to produce. So in theory, if I do this experiment perfectly, if I do the reaction perfectly, I'm going to produce 164 grams of silver phosphate from this reaction. And I always base that theoretical yield on the amount of limiting reactant that I had to use.